All right, we're going to talk now about some ways of counting unions. So what we want to know, so I've got a set A, a set B, and I want to know how many things, how many counting the union of A and B. So how can we go about doing that? Well, we could try to just count them depending on how big these sets are, what the sets consist of. But we can also think about this as some kind of calculation of smaller stuff. So if I think about everything that's in A, that would be all of these things that are just in A, but also the ones that are in A and B. So I'm going to count those. And then if I also do the same with B, I've got all the stuff that's just in B, but I've also got that stuff that's in A as well. So clearly here, this is currently not true because I've counted this once, I've counted this once, but I've counted this bit in the middle twice. So what I need to do then is subtract off the bit that's in the middle, which would be A intersection B. Now, that would mean that I have actually included that middle bit because I've included it once with all of A and another time with all of B. So now I've counted it twice, minus once off. So now I've just included it once. Now, that's how we do the inclusion-exclusion principle with two unknowns. We can rearrange this. So sometimes you might also see it written as A intersection B. And if I add that to both sides, minus this off both sides, we actually end up with something that looks very similar. But it's the same drawing, the same idea. And you can think about this pictorially as everything that's in A plus everything in B. And if I minus off everything, then I've got rid of those two and I've got rid of the double copy and I've only got the bit in the middle. So we can think about it that way. Now, when we go to three sets, we have to just be a little bit more careful about how we do this. So A, B, C. So if I start, I want to know how big is the intersection of, the union of A, union B, union C. So that would be everything in all of these shapes. And if I start by taking my A's and my B's and my C's, then I've got one of each of those currently. I've added this one twice. I've added this one twice because it was in B and C. I've added this bit twice because it was A and B, but I've added this bit in the middle three times. So we now need to minus some stuff off. So if I now minus the A intersection B, well, that would be cutting up one of these, so that would become 1, and that would become 2. Well, that's looking good so far. Let's also minus off A intersection C. Well, that would be cutting off this area here. So I'd have 1 left here, 1 left here. I've really left myself enough space. I also need to get rid of this 1, 2 left. And in order to get rid of that, I'm actually going to take off the whole section here. So that's that's B intersection C. So I'll get rid of that. And now this becomes 0. So I now haven't counted that bit in the middle. So I need to add that bit on again. And that would be the intersection of A, B, and C. And that there is the equation for my inclusion-exclusion principle with three sets.